All right, so we've been talking recently about triangle congruence. And when we talked about triangle congruence, one of the things we talked about was a congruent statement, or in this case, a triangle congruent statement that says triangle blah, blah, blah is congruent to triangle blah, blah, blah. In congruence, if I have two congruent triangles, that means all the angles are congruent and all the side lengths are congruent. So for instance, angle A is congruent to angle Q, angle B is congruent to angle R, and angle C is congruent to angle S. And I really should clarify just a little bit. When I say all the angles are congruent, I'm really saying all the corresponding angles. In other words, angle A isn't congruent to all the other angles, just the one it corresponds to. And of course, the order matters in the congruent statement. So the first letter, these two angles correspond to one another. Third letter, C and S correspond to each other. So that's how I know that angle A is congruent to angle Q, angle B is congruent to angle R, and angle C is congruent to angle S. Likewise, the side lengths are all congruent, and by all, I mean the corresponding side lengths are all congruent. So side AB is congruent to side QR. Side BC is congruent to side RS, and side AC is congruent to QS. Okay, now we're going to take that and we're going to change our frame of reference. We're not talking about triangle congruence anymore. We're going to talk about triangle similarity. Really, we're going to talk about all polygons at first, like any kind of polygons that are similar. But then, just like we did with congruence, we're going to narrow it down to triangles. So let's just compare triangle congruence and triangle similarity for a second here. So triangle similarity. First thing that has to change, and it's no longer a congruent statement, it's called a similarity statement, is that symbol in the middle. This symbol right here. That symbol means congruent. We're not going to say they're congruent if we're not talking about congruent triangles. We're going to say they're similar, and the symbol for that is this, just a squiggle. Next thing is, what about the angles? If two triangles are similar and order still matters, are the corresponding angles congruent? The answer is yes. All the corresponding angles are still congruent. That's still true for similar triangles. So all of this still holds true. How about the side lengths? Side lengths are a different matter. Side lengths are not congruent. All the corresponding, again, it's not really all the side lengths, all the corresponding side lengths, meaning, for instance, side CA and side SQ, which I know correspond because C is the third letter and then A is the first letter. Third letter, first letter, SQ. They aren't congruent at all. They are, and this is a key word when you were talking about similarity, proportional. So instead of congruent, and I'm going to squeeze that in a little bit more, proportional. Okay, so we have a similarity statement with this symbol. My angles are still congruent. My side lengths are proportional. How do I indicate that? To say that side lengths are proportional, I do something that is called a statement of proportionality. Statement of proportionality goes like this. The ratio of AB to QR is the same as the ratio of BC to RS, and that's also the same as the ratio of AC to QS. Okay, so I put my proportional sides in a ratio and said these are proportional because proportion means you have ratios equal to one another. So this is called, and you need to know that, this is called a statement of proportionality. So if you're ever asked to do a statement of proportionality, this is what you are being asked for. Okay, so how do we know if two figures are similar? Well, if we're talking about any kind of polygon beside a triangle, Or if we're talking about triangles and we haven't gotten more specific yet, we have to know that all three of these ratios are the same. We have to know that all pairs of angles that are corresponding are also congruent. Okay, how can I compare two ratios? Like if I wanted to know if, let's say I had 1/4, let's make it a little more complicated than that. How about 2/5 equals 7/17.5. Let's say it's something that maybe not at a glance I can tell immediately is the same. There's three different ways you could tell. Check this, in other words, to check this equality and make sure that this is a true proportion. One way is to cross multiply. 2 times 17.5 gives me 35. 7 times 5 gives me 35. So yes, that is a true proportion. Another way is to change them both to a decimal. So if I go to my calculator and I divide 2 divided by 5, or use a fraction button, and I divide 7 divided by 17.5, I get 0.4 both ways. So yes, they're proportional. And a final way would be to reduce each one to a simplified fraction. Remember, if you have a decimal and you need to reduce, you have to get the decimal to move out. And if I move it one space to the right in the denominator, that moves it one space to the right in the numerator. So I'm simplifying 70 over 175. 35 goes into 70. I probably would have taken 5 out first if I didn't already know this. But 35 goes into 70 twice and into 175 5 times. So yes, it's the same exact fraction once I simplify. All right, so that's how we know what's going on with similarity. Once we know that, one of the things we'll be asked to do sometimes is check and see if we have similarity. Like in this example, if I wanted to check this, one thing you have to be careful of is to make sure you compare the sides that actually correspond. So in other words, if I'm going to compare over here to over here, I'm going to compare the shortest side of this triangle to the shortest side of this triangle. So that would be 6.75 over 4.5. And I would compare the medium length, so to speak, with the medium length over here. So I compare that to 9 over 6. And I can make that comparison, and then I can also make the comparison of either one of those with 12 over 8. You really have to compare your fractions 2 at a time. You can't really do a comparison of all three at the same time. So once you check these, and I can see at a glance that this is 3/2 and this is 3/2. So let's just double check and see if this is also 3/2, and it is. Okay, so yes. So those are all proportional. And I can say, since I already see the angles, I have all the 3 angle congruences I need, that yes, those are similar. You can also set up a proportionality if you need to find some missing information, like in this picture. I need to find X, Y, and W. It says that PQRS is similar to JKLM. So in quadrilateral PQRS, which is right here, I'll probably go left to right, just because that's the way we read. I'm going to say that 25 over W, KJ goes with QP. Sometimes, like in these figures, you can tell at a glance which ones go together. Sometimes you can't, and then you have to rely pretty heavily on your similarity statement. So 25 over W has to be the same as 15 over 12. When I solve that, and you could pause this and solve that yourself if you want, but you should get 20. You should also see 15 over 12 has to equal X over 10. And we can compare that and get, I think X is 12.5. Double check me on that. And all of those have to equal Y over 16. I would probably go ahead and do 15 over 12. And I could also have reduced this from the start and just called that 5 over 4. And then compare like this. I can cross multiply to solve that. Go ahead and do that. You should get Y is 20. Okay, so we could find our missing side lengths if we want to. Now let me just point out one more thing before we stop, and that is that when you are asked for a similarity ratio, You really need to be told the direction. In other words, if I said I wanted the similarity ratio for these two quadrilaterals, I really either need to say JKLM to PQRS or the other way around. If I said JKLM to PQRS, then I find a pair of sides where I know both of them, and I reduce that, which I did, and I got 5/4. And so the similarity ratio of JKLM to PQRS would be 5/4. What would the similarity ratio if I did the opposite order be, from PQRS to JKLM? It would be 4/5. You always put whatever thing is said first on top and whichever is said second on the bottom. Now, like I said, when you're asked for similarity ratio, you really need to be told that, what order they want it in. Because when you're asked for something similar, which is scale factor is a little different. Scale factor has to do with dilations, which is related to similarity. And scale factor is always the new side over the old side. We don't have something like that here because we don't have a new one. We don't have an old one. They both just exist. So that should be enough to get you started on your similarity assignment. Good luck with that. Have fun. And tomorrow we'll talk more, or you will talk a little bit more about the specific triangle similarity postulates and theorems that only apply to triangles and are basically your shortcuts. Just like we have shortcuts for triangle congruence, we have shortcuts for triangle similarity. Have a good evening.